Hello students, so let's come to our next topic of our syllabus. In my last lecture I have told you about processor architecture, Howard and von Neumann architecture. I have well explained you about the Howard and von Neumann architecture. Now let's discuss about CISC and RISC type of the architecture. So complex instruction set for computer. So such type of microcontroller, so CPU is designed to execute a single complex command. Okay, so complex, what is the meaning of complex? So I will tell you. It can execute multiple instructions or steps using a single instruction. Okay, next is the advantage of CISC microcontroller is it's a small sized program. Okay, next is, but due to large size of instruction set with many addressing modes, it makes a multiple machine cycles to execute and cause longer time to perform, right? Another problem is parallel execution of an instruction, which is not possible in CISC type architecture. Okay, so parallel execution is also not possible in the CISC. Okay, sequential execution happens in a CISC, right? So let's start to read it again. Such type of microcontroller is designed to execute a single complex command. Why it is complex? Basically, let's see that what actually happens, what are the steps basically. So here are some of the steps which relate with the computer program. One is add a comma b, right? So for any type of operation, what we need actually, we need to fetch. I am writing just F for fetch, decode of instruction. First it will fetch the instruction, then it will decode the instruction, then it will execute the instruction, E for execution, and then it will fetch, decode, execute, and then it will perform on the operands, and after performing the operation, it will store. S is for store. So in that case, in this one type of data, we cannot do the meaningful execution of this command. Basically, we cannot do a very meaningful operation on this single command, right? What will it do? It will just add two registers which name is A and B. A and B are two registers, and whatever the content in A register, there are two registers. There is one register is A and another register is B. So according to this instruction, it will add the content of A. It is register transfer notation. It will add the content of A to the content of B and store the result in A, right? So that type of operation will happen in that case, right? So basically, it will not fetch any data from A and B. It will work on that, right? While it is whenever we need to do this type of work using CISC architecture. So in CISC architecture, it is a complex thing because it will first fetch the operand. It will first fetch the add, this instruction. It will first fetch the add from the memory, then it will fetch the A, then it will fetch the B, then it will process on it, execute on it, then after execution it will store the result in A. So in multiple cycle it will happen, right? But and if I want to store it in the A, and if I want to store it at some different place, so for the different place I need to write another command, and it is move, say C, any register is C A, so the result will be moved to the C, right? So different type of, for each and every operation there is a different instruction basically, right? So that is a problem in the case of the CISC type architecture, while in in a RISC type architecture it does not happen. So because there is a separate instruction for each and every task, that's why it is a complex in nature. Okay, so it executes multiple instruction or steps using a single instruction, so it need to be execute on a multiple instruction, and but it provide a small size program, right? Because each and everything is a different, clearly explained, so the understanding of the program is good, and program size is also small, right? But it works on a one by one pattern, so parallel execution is not possible in that case. So that's why it is a problem in the CISC type architecture. What's happened in RISC type architecture? And this type of the microcontroller CPUs is designed to execute smaller simple instructions. Since it takes one machine cycle to execute a single instruction, the number of instructions can be reduced to execute a complex task with higher speed than a CISC. What happened in RISC type architecture? Basically, see, there is a level, L is for level, and then there is a stored mechanism, and say there is a stored register where the data need to be stored, and then instruction, and sorry, there is a instruction add A, B, right? Now in a single cycle it will fetch the data, execute on the data, and store the result in A. So there is no any separate instruction need to be provided in that instruction, so that is a reduced instruction set computing example. So in that case what happens actually, it will since it takes a one machine cycle to execute a single instruction, the number of instruction can be reduced to execute a complex task with higher speed than a CISC. Its instruction set size is small, and the program code written for such MCUs are usually very light, lengthy, and consist of many lines. So it is a problem with the RISC type architecture. So these were the you can say difference between CISC and RISC. So I am just finishing my lecture over here. In my next lecture I will tell you about complex systems and microprocessors, and after that I will in my another lecture I will tell you about the characteristics of embedded systems, challenges of the embedded systems, and the embedded system design process. Okay, so thank you for this lecture. In my next lecture I will tell you all these things. Thank you.